Good morning, students. Let me introduce myself first. My name is Vishnu, and today I will be teaching you chapter 10, which is visualizing solid shapes. In this we are going to study about different types of figure of different dimensions. So first let us understand what is dimension. So let us start with 0 dimension, then 1, then 2 and then 3. 0 dimension is when you put just a dot, when you just put a point, that is called the 0 dimension. It has literally no measurements, no length, no breadth, no height. So 1 dimension is when you put a line which has one measurement, which is length. We call that it belongs to 1 dimension. So what is 2 dimension? When you have length and you have breadth, it's 2 dimension, which means it has 2 measurements. 3 dimension is when there is 3 measurements, which is length, breadth and height. So this is length, this is height and this is breadth. Length, breadth and height. Okay, so I hope you understood what is dimensions. Okay, now most of the figures which we can draw on a paper is actually 2 dimensional. Whatever we see in our real life like this duster, this is a part of 3 dimension. And 1 dimension is basically a component of 2 dimension and a 3 dimension. Now let us understand some of the figures of 2 dimension. Okay. First one, let's start with square, rectangle, triangle. These are very common 2-dimensional figure. Okay, square has 4 sides and all the sides are equal. Rectangle, in rectangle the opposite sides are equal, which means this is 5 centimeter, this is going to be 5, this is 10 centimeter, this is going to be 10. In square, if this is 5, this is 5, this is 5, this is 5. Triangle is, and in the triangle we have 3 sides. There are many types of triangle. In some triangle all the sides are going to be equal, in some triangle only 2 sides will be equal, and then there is scaling triangle in which all the 3 sides are different. Okay, now let us understand some more figures of 2-dimensional with different number of shapes, with different number of shapes. Okay, let's see. Triangle, different number of sides. Okay, so triangle has 3 sides. Then we have quadrilateral, which have 4 sides. Now remember, parallelogram or square or rectangle, all these are part of quadrilateral. They all have 4 sides. Then we have a pentagon, which have 5 sides. Okay, triangle. Then we have quadrilateral. Then we have pentagon, which have 5 sides. 1, 2, 3, 4, 5. Then we have a hexagon, which have 6 sides. Then we have a septagon, or it's also called heptagon, which have 7 sides. Then we have octagon, which have 8 sides. Okay, So these are all a part of two-dimensional figures. Okay. Now, if we extend, we will get nonagon, 9 sides, decagon, 10 sides. It will continue like that. Okay. Now, let us understand three-dimensional figures. Three-dimensional figures. In general, three-dimensional figure starts with cube. Just like square, where all the sides are equal, here in cube, this is a part of three-dimensional where all the sides of the figure are same. So if this length is 5, which means breadth is 5, which means height is 5. So this is cube. This is cube, also called, this is cube. Now, let's see one more figure. So this is cube. Now, next to cube, we have cuboid. Now here, in the cuboid, all the shapes are of different length. We have length, we have breadth, and we have height. Let's say this is length, this is 5, then this side, which is opposite to that, is going to be 5. If the breadth here is 6, then breadth here is going to be 6. This is also breadth. This is breadth. This is breadth. These two sides are also breadth. This length. Similarly, this 5 and the bottom here, which is also length, is going to be 5. Now we have height. This is height. This is 7. Then this one is going to be height, which is 7. This is 7. And the one here, this one, is going to be 7. So length 5, breadth 6, height 7. So this is a very common figure, which is cuboid. Okay. Maybe in the cuboid, some figure like length or height may be same, or breadth or height may be same. It's possible. Now let's look at the next figure, which is a cone. This is a cone. In the cone, we have slant height, we have height, we have radius. So see here, this is called slant height, which is usually denoted by small l. So this is L. This here is the height, and this here is the radius. Okay, the bottom part of cone is basically a circle. So this bottom part is basically a circle. This is radius, this is radius, this is height, this is line height. Okay, so this is called a cone. Now let's look at cylinder. So in the cylinder, we have two circles at the top and bottom. Okay, so in this we do not have slant height. In this we do not have slant height. We have height and radius. This radius is and this radius is going to be same. This is 5 cm. This is 5. This is 6. This is 6. It's like that. Height in varies. Okay. So this is cylinder. These are all part of three-dimensional figures. Okay, very common figures: cube, cuboid, cuboid, cone, cylinder. Okay. So now let us look at page number 153, the very starting page. In this, match the following. First one is done for you. It says, So in the first one they have given a shape which is I think cube, which is a square. The square belongs to 2 dimension, and name of the shape is square. Next is we have a cone. Cone we know is a 3 dimension, and the name is, it's in the back of the page, which is cone. Next we have a cylinder. Cylinder is 3 dimensional figure and it's given there cylinder. And then we have a triangle. Triangle we know is a part of 2 dimension, and it's called triangle. The fourth one is triangle. The fifth one is a cuboid. It's a cube. So cube we know is a part of 3 dimension, and it's called cube. The sixth one is a circle. Circle, yes, I forgot to tell you, circle and sphere. Sphere is like the combination of 4 circles. Okay, read that. Just understand circle. Okay, circle is a part of 2 dimension. It's a part of 2 dimension. Okay, circle is a part of 2 dimension. Whereas a sphere forms when we combine 4 circles. Okay, we get a sphere. Earth is a spherical shape. So that kind of shape is a part of 3 dimension. Okay. So this is a simple circle. This is a simple circle. So circle belongs to 2 dimension. Okay. And the next one is a cuboid. Next one is a cuboid. It's part of 3 dimension. It's called cuboid. And the next one is actually a sphere, which is part of 3 dimension. Okay, to show that it's a sphere, they have made like this. So to show that it's a sphere, but it's very difficult to show it in a paper. Sphere 3D dimensions, especially if it is a sphere. Now let us look some of the views of 3D shapes. Okay, now in the page 155 they have given a house. And it's a hut. It's a hut. And whichever side is towards us, they will say it's a front side. And whichever is towards right side or left side, we say it's a side view. And whichever is on the top, we say it's the top view. Okay, so they have given in the page number 155 views of 3D shape. They have a hut, and as you can see, the front shape is called front view. The top is called the top view. And side is called side view. Okay, so we need a little bit ability to visualize these things. Okay, with practice we can get that. Okay, now let's look at one page. Take exercise 10.1, page number 158, question number 2. For each of the given solid, 3 views are given. Identify for each solid the corresponding top, front and side view. The first one is an almirah. So in the almirah we have the first shape that is given is the front view. Yes. The second one that is given is actually the side view. The third one that is given is the top view. So it's called top view. Next one is a matchbox. The matchbox, the first view that is given is side view. The second one that is given is the front view. And the third one that is given is the top one of a fish, that is the top view. The third figure that is given is a computer, is a television. The television, the first that is given is the front view. We all know that is the front. The second that is given is the side view of the television. And the third that is given is when you look from the top, so that's the top view. The fourth one, the D that is given is a car. In the car, the first one that is given is a front view. We know the front, that's the front of the car. Next is the side view of the car, and the third one that is given is the top view of the car. Now let's look at question number 3 of the exercise 10.1. In this, for each given solid, identify the top view, front view and side view. Now for some students they may find it difficult, but like I said, if you practice 2 or 3 times you will be able to understand that. So the first one that is given is a figure. In that figure, the first option that is given is the top view. The second one that is given is the side view, and the third one that is given is the second one that is given is the front view, and the third one that is given is the side view. Okay, they have clearly mentioned it in the book, front, top and side. You just have to find out those sides, okay, after seeing it. Now the second one, B, there is no special technique or anything to identify. We just have to visualize them and match with the figure, and we will get the answer. The second one that figure they have given, the first option, that is the side view, and the second one that is given is the front view, and the third one that is given is the top view. So see, in that the first one that is given is actually the top view. The second one, if you have any confusion, just we know only three views are there: top, side or front. If you are not sure whether it's top view, then stop there, just move to the second one and see. This way you can find out, by eliminating you can find out. We will get the side view and then front view, then you automatically know that the first one was the top view. Let's say if I don't know, the first one was top view. Fine, let's move on to the second one. If you look at the second one, it's very clear, three sides are given. So this is the front view. The next one, if you look, that's from the top, that is from the front view. So the third one is front view, the second one is side view. So automatically you will know the first one was actually top view. Okay. So now look at D figure. In the figure D, the first one, okay, the first one, okay, I can understand the side view. The second one, look at the second one. Second one, it's very clear, it's the front view. The third one is very clear, it's the top view. Okay. Now if you look at figure E, the first one, okay fine, it's a little confusing, wait. Now let's look at the second one. Second one, it's clear that it's top view. The third one, it's clear it's the side view. So automatically you will know the first one was actually the front view. So in case you do not know one of them, you have confusion, just move on to the second one and solve the second one, get the answer for the second one. Then move on to the third one, get the answer for the third one. Automatically you will know the first one was actually whatever is left of them. Okay, so if the second one you got top view and the third one you got side view, then you will automatically know the first one as actually front view. Okay. Now, mapping space around us, it's basically like a workshop kind of thing. So in this, you have to make diagram. In exercise 10.2, you have to make some of the maps of your classroom. So I am giving you this as a homework. Okay, just look at the first one. Okay, look at the first map. You have to make similar maps. Okay, so here the question number 2 and 3 I am giving you as a homework. Okay, it's just a workshop for you. You have to do it on your own. Draw a map of your classroom. So the question number 2 and 3 I am giving you as a homework. Okay, draw a map of your classroom using proper scale, symbol for different objects, and draw a map of your school compound using proper scale, symbol for various features like playground, main building, garden, etc. So in the school, in the classroom, what and all we have a board, we have multiple chairs, tables, yes, and what and all, we have many charts and all. So you have to just mention, make a map of that. Okay, windows are there, fans are there, so you have to mention all these things, and if you could make and draw it, it's well. Next, in the school we have a playground, yes, we have a gate and all. So we have multiple blocks of buildings. Okay, so you have to mention all those things. We have a road which is connecting them, so you have to make a map of all those things. Okay, so that's a homework for you. Now let us understand face, edges and vertices. It's very, very important. So faces, edges and vertices. So listen, when we are talking about faces, edges and vertices, we are basically talking about a three-dimensional figure. So see here we have a figure which is a cuboid. Now in this, let us understand what is face. Okay, let us start this with a simple example. Look at this mobile. Assume that it has a little bit breadth. Now the front side that you're seeing is called the face. So here in this figure, the front side, which is this one, this is our face. This is one face. Here we have one more face. In back of this we have one more face. Inside of this we have one face here. In the bottom one face and top one face. How many faces are there now? 1, 2, 3, 4, 5, 6. So we have 6 faces. Now let's look at the edges and vertices. Edge is this one. Edge is called, this side is called edge. This side is called one edge. This side is called one edge. So how many edges are there? Let's look at here. On top we have 1, 2, 3, 4. Top we have 4. Bottom we have 4. So 8 plus here 1, here 1. Because this is already counted and this one is already counted. So 1, 2. Here 1, 2. So 2, 2, 4. And I think we have 12 edges. Top 1, 2, 3, 4. Bottom 1, 2. 1, 2, 3, 4. Side here 2. Side here 2. So 8 plus 4, 12 edges. Now the vertices. So what is vertices? So face we have 6, edges we have 12, and then vertices. How many vertices are there? See here. This is one vertex where two lines join. That point is called vertices. Okay. So here we have 1 vertices. Here 2, 3, 4. 4 vertices. And then here 1, 2, 3, 4. So 8 plus 1, 2, 3, 4, 1, 2, 3. I think 8 vertices are there. 1, 2, 3, 4, 5, 6, 7, 8. So 8 vertices. Vertices is 8. So here in a cuboid or cube, we will have 6 faces, we will have 12 edges and 8 vertices. Okay. So similarly, not all the figures will have faces, edges and vertices. It's not very common. Like if you go by the cylinder and all, there will be slight changes because the bottom and top will be circle. Okay. So now let us understand what is polyhedron. It's very, very important. Polyhedron. Let me read out the definition of polyhedron. Each of these solids is made up. Okay. Look at the page number 164, and you will see some figures, which is a pyramid. First one is like a pyramid. Second one is also like a you put a pyramid on top of a cuboidal surface. You will get that kind of pyramid. And third one is just a cuboid. Okay. So look at the definition of each of these solids is made up of polygonal regions which are called its faces. These faces meet at edges. Yes, faces actually meet at edges. Okay, these two faces meet at edges, and which are line segments, which is actually line segment. Yes, and the edges meet at, and these edges meet at vertices, which are points. Yes, actually they are points. Such solids are called polyhedron. So we are talking about a figure. Polyhedron is any figure which have actually face, which have edge and which have vertices. In simple terms, polyhedron is a figure which have face, edges and vertices only. That has to be very clear. Only, nothing else. It must have faces, edges and vertices only, and which means basically there should be only line. No circle. We are not talking about a figure which have a circle in it. We are talking about a figure which have only lines. Okay, so that is polyhedron. So now look at the page number 164. After the top, after this top, there is one more here. two figures are given. Okay, so they say the left side figures are called polyhedrons and the right side figures are called not polyhedrons. Why not polyhedrons? See, the first one is a circle, or assume that is a sphere. It's okay. It has a does it have lines only? No, that's not possible for a circle or a sphere. The second one is a cylinder. The second one is actually a cylinder. I told you already in the beginning of this session that here it's circle, here this is a circle. There are two circles. Here the edges and all are not getting connected by lines. Yes, here it's a circle, here is a circle, so this is not polyhedron. The third figure is a cone. The third figure is actually a cone. In the cone also, the bottom, the edges are not meeting by straight lines. Here we have a circle. So this is also not polyhedron. So now let's look at what is prism. What is prism? Okay, basically a prism can have 4 sides or 3 sides or 5 sides, it's okay. But the only condition is whatever you will have here, you should have the same, whatever you will have here in the front, you should have the same view in the back side also. So you see here in the page number 165, whatever these two figures are called prism. So here see, whatever you have in the front, you should have in the back. So in the front view, let's see, let me draw it. So let us assume this to be prism. Okay. Now see here, the top is a triangle. If the bottom is also a triangle, then this is a prism. If the top is actually a rectangle, then the bottom should also be a rectangle. Then that's a prism. If the top is a pentagon, 1, 2, 3, 4, 5, 6, hexagon shape, the bottom, if you draw like this, the bottom should also be a pentagon shape. Then it's a prism. Okay. Now what are pyramids? So here in the pyramids, mostly we will have its shape like this. We will have a shape similar to this. What happens is there is a base. This base can be a triangle like this. This base can be a triangle like this, or this base can be a quadrilateral like this with 4 sides. 1, 2, 3, 4. And on top of that, we will have a certain face which is triangular in shape. So it's like this. Okay. See, this side is one triangle. 1, 2, 3. This side 1, 2, 3. This side 1, 2, 3. And the back of that there is one more triangle. Okay. So we have 4 faces. This is right side face. This is front side face. This is side face. And behind we have back side triangular face. So this is how a pyramid is there. Basically, pyramid can have square, rectangle, or maybe circular is also possible, or maybe a triangular base. Base could be anything. Okay, that depends. But in the prism, remember that the front and the back, front view and the back view should be the same. Okay. See, now the definition of prism is, we say that prism is a polyhedron whose base and the top are congruent polygons. Polygons is any figure with more than 3 number of sides is called polygon. If 3 or more than 3 number of sides are called polygon. Okay, whose other faces, that is lateral faces, are parallelogram in shape. So the other shapes, so when I draw, see here, this is triangle and this is triangle, okay, of the same measurement. Next, look at these two sides here, these are parallel, yes, these are parallel. So, this side and this side is parallel. So, he is saying that the top and the base and the top are congruent polygons, and the other faces, that is the lateral faces, are actually parallelogram in shape. So it's very difficult to understand from here, but see this 1, 2, 3, 4. So that's one side which is actually a parallelogram with 4 sides. Here, look here, this one, this is one side, one face which is actually parallelogram in shape. This is here, see here, this is actually parallelogram in shape. Parallelogram means parallel sides are parallel and equal in length. Okay, so the pyramid is a polyhedron whose base is a polygon of any number of sides, okay, whose lateral faces are triangle with common vertices. Okay, so pyramid is a polyhedron whose base is a polygon, which means 3 or more than 3 is possible, and whose lateral faces are, in case of pyramid, the lateral faces are, see, the lateral faces are, this is one face, here we will have this one face, towards us this is one side face, and behind we will have one more face. So 4 lateral faces are there in this pyramid. Okay, so it depends upon the number of sides. If there are 4 sides, there are 4 sides in the base, in the bottom. See, bottom is actually a rectangle. So rectangle has 4 sides. Then the number of faces is 1, 2, 3, 4. If the bottom is actually a triangle, if the bottom is okay, look here. Okay, this is one pyramid. If the bottom has 3 sides, we will have 3 faces, lateral faces. One here, this one here, and behind that one more sides will be there. So it depends upon the number of sides of the bottom figure. If the bottom figure has 4 sides, then we will have 4 lateral faces. If the bottom figure has 3, then we will have 3 lateral faces. Okay. Now I hope prism and pyramid is clear. Now let's look at Euler's formula. It's very, very important. Now you know that the edges, the faces and vertices are connected. Somehow they are connected. Yes or no? In the pyramid itself we saw, if there are 4 sides in the bottom figure, we will have 4 lateral faces. If there is 3, then we will have 3 lateral faces. Similarly, edges, faces and vertices are connected. connected, and that connection is explained through this formula, which is Euler's formula. Okay, now Euler's formula is F plus V minus E is equal to 2. So to identify whether a given figure is a polyhedron or not, you just have to apply this formula to find out whether a figure that is given to you. Let's say I am telling you a figure has 5 edges, 6 faces and 10 vertices. Now you have to find the figure that I have given to you is a polyhedron or not. So what you will do to find polyhedron or not, you just have to apply the values here. How many faces I told? See, this I told 5, this I told 6, this I am telling 10. Okay, let's apply this. Faces 6, vertices 10, edges 5. If the result is 2, then the figure, whatever details I have given you is the details of a polyhedron. See, 6 plus 10, 16 minus 5 is equal to 11. What I told you, you should get 2, but did you get 2? No, we got only 11, which means this details doesn't belong to a polyhedron. Okay, this details doesn't belong to a polyhedron. To identify whether certain details of edges, faces, vertices belongs to a polyhedron or not, all you have to do is apply this formula. Okay, so let's take one example here. Look at exercise 10.3, question number 7. Using Euler's formula, find the unknown. Using Euler's formula, find the unknown. Okay. So, okay, let's solve this. So, in this, it's given like this. We have faces, we have vertices, and we have edges. This is question number 7. Okay. We have faces, we have vertices, and we have edges. So faces, the first one, the face is question mark, then 6 and then 12. Okay. So let's solve and find the face using Euler's formula, which is F plus V minus E is equal to 2. Now let's solve it. Faces, how many faces are there? It's not given, so let's keep that as face only. This is what we have to find. Plus V. V, how many are there? 6. Edges, how many are there? 12. We will keep that as 2 as it is. F 6 minus 12 plus 6 minus 12 gives minus 6 is equal to 2. F is equal to 2 plus 6, 8. So remember, the answer is 8, which means if you have 8 faces, 6 vertices and 12 edges, that is going to be a polyhedron. Let's check that. Let's verify that. Okay, let's verify that. Let's verify that. How many you got? Faces we have 8, vertices we have 6 and edges we have 12. Okay, now let's verify that using Euler's formula. So I am giving you a question. There are 8 faces, 6 vertices and 12 edges. Now you have to find out whether this given details belongs to a polyhedron or not. Okay, now you have to apply the Euler's formula. F plus V minus E is equal to 2. See here, now let's put this value here and we should get the answer 2. F 8, vertices 6, edges minus 12. 8 plus 6, 14 minus 12 is equal to 2, which means we got 2. That means this is a polyhedron. This so-called given details belongs to polyhedron. Okay. Similarly, let me solve one more. The second one. The second one has faces, vertices and edges. Faces, how many are there? 5. Vertices is missing, question mark, and then 9. Let's solve this. Let's find the vertices using F plus V minus E is equal to 2. See, if we have to verify, then we won't put this value. Okay, we have to get 2. If we have to find something which is missing, then we have to put the 2 and make that part of our solution. Okay, so here f is 5, vertices is v because it's missing, edge is 9 and then 2. Okay, because we have to find the value of v, we have to use this 2. If we have to verify it whether it's a polyhedron or not, then we don't have to put that 2 here. We have to get that 2 while solving. That's how it works. So 5 plus, keep the v here, plus 5 and minus 9 gives minus 4 is equal to 2. V is equal to 4. If you took from here to there, you will get 2 plus 4, which is equal to 6. So the answer is 6. Now if you want to verify it, we can verify. Let's verify that. F plus V formula is F plus V minus C is equal to 2. This is what we have to get when we have to verify it. Okay, so we will take the left hand side only. F is 5, V is 6, and then H is minus 9. 11 minus 9, we got 2. LHS is equal to RHS. Hence, verified this is a polyhedron. Okay, so the third one I am giving you as a homework. Okay, which is 20 faces, 12 vertices, and edges is missing. So you have to find that. That is your homework. Now, so look at question number exercise 10.3, question number 6. So this figure is given. See in the question number 6 there are 2 figures given. We will solve the second one. Okay. In the second one, first let us find out the number of faces. Verify Euler's formula for this solid. So we have to verify. So for that we have to find the number of faces, edges and vertices. Faces, how many there? 1, 2, 3, 4 faces are there. Here one face, there one face. 1, 2, 3, 4 faces. Now, no, not 4 faces. More than that is there. 4 plus. Top 4 faces are there. Then bottom we have 1, 2, 3, 4, 5. So 4 plus 5, 9 faces are there. 1, 2, 3, 4, 5, 6, 7, 8, 9 faces are there. Then look at the number of edges. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Then look at the number of vertices. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's put this in formula and let's see what we are getting. So formula is F plus V minus C is equal to 2. We are just going to take the, because we have to verify, we will take the LHS only. Taking LHS, F is how much? 9, V is how much? 9, E is how much? 16. 18 plus minus 16, we are getting 2, which means LHS is equal to RHS. This is a polyhedron. This is a polyhedron. Okay. Yes, by seeing it, we can easily identify that as a polyhedron because there is no circle in this figure, which means we got the right answer only. Okay. So the first one I am giving you of the question exercise 10.3, question number 6. The first one I am giving you as a homework. Okay. Now look at exercise 10.3, question number 1. Can a polyhedron have for its faces? The question is, can a polyhedron have for its faces 3 triangle arc? Is 3 triangle possible for a polyhedron? First of all, it's not possible. Look at the pyramid here. Look at this pyramid, triangular pyramid in the page number 165. You can see on the top itself there are 3 faces. If top itself have 3 faces, there should be a face in the bottom itself to connect these faces. Top, if you have 3 faces, you can't just keep 2 faces like this. You can't keep 2 faces like this. 1 and another 2 like this. Okay. In 3 dimensions it's not possible. You need a in the top itself you need 3 figures, 3 triangular faces, and the bottom you need one more triangular face or a cuboidal or a rectangular face to connect them. So is it possible to have 3 triangles for a polyhedron? Question number 1. That is the question number 1. No, it's not possible. Now let's look, is it possible to have 4 triangles? Yes, it's possible. Look at page number 165, the second figure, where there is a triangle in the bottom and there are 3 faces, lateral faces. So we are having actually 4 triangles. So it's possible. Now the next question is, can we have a square and a 4 triangles? Yes, it's possible. See, here in the same pyramid, if we keep this bottom figure as a square and on top we have 3 or 4 triangles is possible. See here, 4 triangles are possible because I already told you, if the bottom side has 4 sides, the top will have 4 lateral figures. So if the bottom is triangle, we will have 3 lateral faces. If the top bottom is a figure with 4 sides, then the top we will have 4 lateral faces. So yes, it's possible. The third one is possible. We can have a square in the bottom and we can have 4 triangle sides. It's possible. Okay, now let's look at question number 3. The first one, a name. Is it a prism? No, it's not a prism. No, it's not a prism because one side it's a point, another side it's a circle. So it's not possible. The unsharpened pencil. The second one is unsharpened pencil. Is it a prism? Yes, it's absolutely a prism because the front side, I think 1, 2, 3, 4, 5, 6. Yes, it's a hexagon, and the back side is also going to be a hexagon. If you have seen the pencil, a unsharpened pencil, you will understand if the front side 1, 2, 3, 4, 5, 6 is a hexagon, so the back side is also going to be a hexagon. So this is a prism. Now the paper, a table weight, is it a prism? No, it's not prism because the bottom side, the bottom side is like a rectangle, the top side is a point. So it's not a prism. This is a pyramid. The fourth one, is it a box? Is it a box a prism? Yes, a box is a prism because the top is a square and the bottom bottom will also be a square. So it's a prism. Okay. So I'm giving you one more question as homework, which is fourth one. How are prism and cylinder alike? Prism and cylinder alike. Let me explain to you. Then the second one I will give you as a homework. See here. What is prism? Prism has a concept that the top and the bottom should look like same. So in the cylinder we have a face like this. See, I already told you if this is 5 cm, this is 5 cm. This looks like a circular prism. A cylinder is nothing but a circular prism. Okay, so yes, they are connected. Okay, prism and cylinder are alike, and the connection is the top and the bottom are circular. So that's why this is in a way a circular prism. A cylinder is in a way circular prism. So the second question, how are pyramids and cones alike? That's a homework for you. You find out. The fifth one is a square prism same as a cube. Square prism and cube are somehow related. So you find that also. That's homework for you. So total homework that I have given you is from exercise 10.3. Exercise 10.3. The fourth one, in the fourth question, second one, and the fifth one. And in the seventh question, the third one, where the edges is missing. And you have to verify the 10th one also. Can a polyhedron have 10 faces, 20 edges and 15 vertices? That is also homework for you. From exercise 10.3. Okay. And from exercise 10.2, I am giving you this is just for your practice, okay, and just for your visualizing abilities. That's the question number 12. Okay, students, that's it for today. I hope you have understood this chapter, and we are done with this chapter. Thank you very much.